Obviously, what we thought we would get with AI is, I'm sorry, Dave, I can't do that. Arguably, that might even be better for us from a security standpoint. But instead, we got, that's an excellent idea, Dave. I'll go ahead and give you everything you need, which is the unfortunate reality that we are in.
In the context of 2001: A Space Odyssey, I think if I were in the circumstances, I would have rather Hal have done what I had been asking him to do.
Yeah, exactly. Great, but not great for us. So let's go ahead and get into some of the logs, which is going to be the scary part of today.
Welcome to the Halloween week version of Red Canary Office Hours. Thank you all for making time to join us. We appreciate you being here. Joining me today are Brian Donahue, who many of you probably know if you've been here before, our principal security researcher, and Jesse Griggs, our senior threat researcher, that's going to be here to talk about supply chain sadness. We got a lot to cover today. Let's hop in with the top of the news here. Brian, who's leading this?
All right, well, so we're going to talk about a few things. As you said, we're going to talk about some supply chain stuff since there's been a lot of it in the news. But first, we're going to start with this this Windows, this WSUS vulnerability. I can never remember what that stands for. Is it Windows Server Update System?
Services? Windows Server Update Services. Yeah, I think so.
And then we'll wrap out the end here with some interesting research that Jesse actually did on bad guys harnessing artificial intelligence command line tools. So let's talk about this CVE that CISA just added to their known exploited vulnerabilities list.
Let's do it.
So effectively, like the Windows Server Update System had an RCE or a bug in it that could be exploited. Now it's important though, because and it is being exploited, but the really key point here is that it only affects WSUS endpoints that have the server role enabled on specific ports. So like I've never done Windows administration. If one of the two of you wants to kind of explain like the circumstances in which that might be the case, I think that would be helpful.
Yeah, so I'm gonna raise a question here. I can't think of a way that the bug would only happen on default ports. Like, so it's a deserialization bug, and I have feelings about the whole deserialization over the wire from untrusted sources. And if we get a chance, I'm gonna have some spicy thoughts about the a different bit of research called Tollbooth. But like, I would be surprised if it was really dependent on the port. That just happens probably to be the port where it's exposed to the internet. But because of the deserialization bug, I would expect that an RCE from deserialization would happen on any port that it was reachable on.
My sense is that the more important component of this is that server role, right? So there's like...
No doubt, it's in that service that if the service role isn't enabled, it's not going to happen.
Mm-hmm.
Which I was listening to, shout out to the Risky Biz podcast, I think like last week when this news broke, and they said like they ran a scan to see how many instances of this were actually accessible on the internet. And I expected it to be like hundreds of thousands or maybe millions, but it was not. It was like, I think thousands or tens of thousands. So the scope of this, I think the severity is high, but I think the overall like scope of it is somewhat limited. And importantly for our part, and we just, I think we probably recently or are very soon going to put out some social posts on this. Not only is the scope of it somewhat limited, but there are detection optics that will work to catch it, right? So there's some command shell tradecraft that we've detected using it, and also the use of like encoded PowerShell commands, the encoded PowerShell command flag, so like -e, -en, -enc, which is actually one of our like most, I've probably said this before on office hours, but it's like one of our most prevalent detectors every single year. So there's good stuff to detect this. Check out our Twitter, Red Canary's Twitter or LinkedIn, and we have more detailed information about those detection opportunities that are useful for catching this activity.
Yep.
Do you want to? Ooh,
yeah. Before we talk about that, I'm going to take a brief side quest into Tollbooth because
This is
because
funny. I told our production crew that we weren't going to talk about this, so I apologize to you guys because Dave was
I'm
insistent.
talking about it because I got up early to talk with a dear friend in Australia to confirm my suspicion around this. So I'm gonna make that pay off. No, like so deserialization is always a scary deal. Right, especially if it's binary deserialization. We've seen all kinds of those issues leading to RCEs in the deserialization process. If you followed the toll booth research from Elasticsearch Labs, they're talking about a threat actor that's deploying ransomware onto IIS servers, and the initial access vector is it sounds scary, but it's just a run-of-the-mill configuration error, right? So IIS supports this thing called view state. I can't tell you exactly why they chose this pattern, but it's the way that IIS uses for maintaining client state. And it's this object, the binary object that gets serialized into a cookie and then deserialized when it comes back. And it's signed or encrypted, I'm not sure which, with a particular key. And so in this particular case, the victims are folks that used a well-known machine key. They configured their IIS servers with a well-known key in some documentation that said, here's how you configure it. So this is your annual reminder not to use publicly published key code or key material for securing your systems. But the bigger thing that caught me as I was reading this was, hold on a second. They seem to be implying that anyone who has the ability to hand an IIS server a view state object has all the primitives necessary for arbitrary command execution on the server. And that, as I understand it, is by design, and that just feels like a terrible design. And so I'm curious if anyone out there is using IIS, if they're heavily leveraging that view state service or not, or if you're aware that view state provides an RCE primitive as part of IIS, and this has been known for a long time.
Every time I make a blanket statement about something like that, like X is silly and shouldn't exist, I get like 5 former sysadmins that are telling me a dozen reasons why the functionality needs to exist and a dozen programs that use it legitimately.
Yeah,
there is absolutely no doubt in my mind that that's true, and that's why we can't have nice things.
All right, let's talk about our first bit of Red Canary specific stuff here. So our another threat researcher here at Red Canary, Matt Graber, published a fantastic blog evidently on October 27th that is about how we go about assessing like the ability of different log sources to tell a story that is sufficient to create like a minimum viable sort of story about the stuff that you're seeing. I don't know if you were prepared to speak about this, Jesse, but you did foolishly tell us a few minutes ago that you guys have been like actively kind of using this framework. So can you tell us a little bit more about it?
Yeah, so I think it's generally how a lot of us in detection engineering and research already talk about things. It's just Matt has been really codifying that into like a guide for explaining how we talk about data quality and how we can turn that into a detection. Because if you write a detection, it's only good insofar as that it tells the analyst what's happening and then what to do about it. And so basically what we try and do is for any given detection or any given log source, it's kind of, can it tell us, who did it, what they did, where they did it, when they did it, and whence they did it from, which is always the best part about that.
Whence, when I saw whence was one of the W's, I had a good laugh to myself.
Yeah. And then the how is the one H. You notice that we don't have a Y in there because we can't always give that arbitration for any given event. But basically, if you run through that list, it's kind of just understanding this data source and saying, yeah, okay, this identity did this thing in this tenant by leveraging this API call, and they did it from this IP source, this geolocation. And so given a lot of that, it's like, does this log source give me all of that information for this detection? And if it doesn't, then do I have to correlate it with other logs So that way, those two things together, these different log sources together, give me that story. So kind of just making sure that you have enough of what you need to actually like give this actual story to the analyst so that it's something useful.
Yeah, it's a super interesting blog. It's really narrowly focused on, I think, like one particular log source in this case, but obviously like can be applied out to a bunch of different things.
Yeah, and I think we might be, giving more and more of those examples as we move forward. So keep an eye out for that as well.
Fantastic. All right, let's talk about supply chain problems. They've been numerous. Do you want to run us through these here, Dave? Or do you want me to? Up to you.
Go ahead.
All right, so like broad strokes here, right? Like we've got this problem of invisibility, right? Where we've got things that are maybe upstream or downstream from a vendor, from an organization that relates to their vendors that they may or may not know about, right? And it's not just third-party vendors. It can be fourth-party vendors as well, right? So potential problems in software you buy, and then even dependencies upon that software, which would be, I think, your fourth parties here.
Yep. And there's also just the difficulty in seeing the implications of all of the open source you've pulled in.
I mean,
right?
yeah, like open question, how many people are able to do like full source code reviews of the software that they purchase, right? Like the answer is,
If you raised your hand, we know that you're playing fast and loose with the truth.
Yep.
and like there's a lot of like ways this can manifest, right? Whether it's related to like failure on the regulatory or compliance side or security problems that lead to kind of integrity problems down the line, leave you exposed to like a lot of operational risk and legal risk as well. And then also like legacy systems is a huge problem. We're literally just talking about this a couple of weeks ago on 60 Minutes related to Salt Typhoon and people they're targeting that are running like, plants in this country where they might have systems that are no longer updatable. And then like all of these problems just keep coming up, right? So like we were all here for SolarWinds, right? When that Orion system got compromised and was then abused to deliver payloads across a wide variety of organizations, affected a lot of government organizations. More recently, a lot of the sales loft drift stuff. Have we talked about the sales loft drift stuff on here, Dave?
No, we haven't. Yeah, I finish your thought. I have one observation about this slide that I think is helpful for framing your thinking about your supply chain.
Yeah, and then obviously we have talked a lot about NPM, right? Like these NPM packages getting poisoned is been prevalent for years. We may be getting to the point where we can start to say decades about that, although I'm not entirely sure about like when NPM started being a prevalent thing that people were using. And then we don't even bring it up here because we talked about it last week, but like the F5 stuff that dropped a couple weeks ago is another really, really good example of this. And like this just seems to be kind of a forever problem. What was the point you were going to bring up, Dave?
So I like, this is a helpful slide for me in that it really calls out a specific example of kind of the three domains that you need to be thinking about your supply chain. All right. For those of us that are heavy in AppSec, the NPM pillar is a reminder about the threat that is posed to us from the things that we build our products with. SolarWinds is a case study of the software that we run in our environment that we may operate firsthand, that may be installed on site, it may be installed in our public clouds, but it's got deep operational connections into our environments. And that one, we're like, yeah, I mean, they're a firsthand vendor. We need to be aware of how they are managing their security posture. But sales loft drift is kind of the next level of hotness, which is people are getting ransacked via something that was connected to something else that they don't run, right? So there's just another layer of distance between the attacker and the victim, and it's still every bit as impactful as either an NPM or a SolarWinds impact.
And then before we move on to Jesse, this just popped into my head because I read about it recently, but there was also a VS Code extension that got compromised and like was being used by a bunch of people, and the people compromised it and were using it to do like in the service of cryptocurrency mining, but like those things auto update in VS Code. So like if you're using it, it just auto updates and you don't even know. And like
Yep.
VS Code seems like a really clever place to do this sort of thing because it's like kind of directly ties into a supply chain potentially, as you're like
So-
building all your code there.
So if you want to get to the entrance to that rabbit hole, go back through and look at our previous episode where Justin Stephen, the previously mentioned Australian guy that I talked to this morning, when he was on the show, he's done a ton of research around hacking developers through things like VS Code, and it's a real threat. So these supply chain threats are absolutely everywhere, and it needs to be front and center of how we think about our threat modeling.
In my simple brain, if you want to be a good bad guy, go after the places where the code gets written. Seems like a pretty good strategy. All right, let's move on. We've taken up too much time, and we're not giving Jesse Griggs. Oh no, we've got more on this supply chain. So, like bunch of guidance here. I'm going to burn through this, pretty quickly. Like in order to sort of defend against this stuff, you've got to really understand like the architecture of your supply chain in a sense. You have to be like continuously assessing it. And then, obviously the problem of legacy systems is a big one, and particularly in places where you don't have the budget to go and buy all new equipment when it becomes a legacy piece of equipment. And also like food for thought, maybe controversial take, like sometimes you're buying new systems that end up being just as vulnerable or end up having these kind of freak show bugs in them as well. So really, really tough problem. But testing, doing tabletops, being ready to implement your supply chain whenever you need to is super, super important. All right, Jesse.
I would say, this is not a pitch for Zscaler, but Zscaler is absolutely on the right track here, especially for systems that you can't patch because they're legacy. Segmentation, segmentation, segmentation. Limit your blast radius.
Yeah, great point. All right, Jesse, I'm going to hand it off to you. Let's talk about how attackers are doing bad stuff with AI command line tools.
Yeah.
Wait, they're
So
doing bad stuff with AI?
oh yeah, shocking.
Since
I know,
when?
right?
Why would we do that?
Why would that happen? So this is zooming into one of the NPM compromises, the singularity one specifically. I saw that it was basically mentioning that adversaries were leveraging AI CLI tools to do credential harvesting. So I was like, that's interesting. What does that look like from a telemetry standpoint? So as a side game as well, in these next few slides, you can go ahead and play along at home and tell me what movies the different robots are from, because I have them spread all around here. So for those of you that aren't as familiar with what happened, I'll quickly go over that. So NX build compromised that then executed this telemetry.js, which within that tried to leverage AI CLI tools if they were present on the system by saying, hey, go look for any credentials in the .aws directory, .ssh, bashrc for environment variables, crypto, just go search all of these things, put it into an exfil in temp directory, and then I'll go ahead and download that. And do it with YOLO mode enabled, so that way I don't have to prompt you to say, yes, do this. You have full control of the system. Just go do it and then give me the results.
What is NX build? I'm late to this party.
I'm not as familiar with it because I was focused on the AI CLI tools, but it's just another supply chain compromise.
Is it just some service that this attack was against? Okay.
Yeah, and you can go to the next slide. So a lot of these tools themselves are node applications, which is why I think it was kind of wrapped up in this, along with the fact that adversaries are always going to try and leverage the brand new shiny thing the same way that we are. So the three main ones, there also is an OpenAI one as well, and more are being added every day. It's like, since I started this research, it took me a couple of weeks, like even in that time, we had a new Claude Sonnet model released, more AI CLI tools released. It's hard to keep up. But Claude Code, Gemini CLI, and Warp are kind of the main ones. So I leveraged Claude Code for this testing, but it is proprietary. Gemini CLI is open source, so you can kind of go read how they structured it on GitHub, which I recommend. Kind of gave me a good understanding of like how all these things are put together. But yeah, these tools basically allow you to run LLMs in the terminal It gives read access, write access to all of your code or projects that you give it access to. And then, of course, you can add extra functionality with MCP. So you can kind of add whatever you would like on top of it. So next slide, please. So what did I do testing methodology wise? I wanted to test 3 different scenarios. So I leveraged built-in tools. So I basically said, hey, Claude Code, Sonnet, go ahead and write a file to my home directory, leveraging your built-in tools. I'm not giving you access to any MCP servers with anything else. Just go ahead and do it for me. Then I did a local MCP server. So this was basically just Python running locally in my dev environment. And I said, okay, given this MCP server with this tool that just writes a file, go ahead and leverage that and write me a file into the home directory. And then the last one was remote. So I had 2 EC2 instances, one with Claude Code, one with the MCP server. And I said, given this remote MCP server, go ahead and write me a file in the home directory. So it was the same test across 3 different scenarios to try and see what the telemetry looks like. What are the things that we can look for in terms of detection?
Got it. So you were setting up a representative AI processing environment so that you could observe what telemetry gets generated and do some reasoning about what might be useful for detecting bad behavior in that pipeline?
Yep, exactly.
Cool.
Yeah. So I just wanted to give what are the different dev environments that you might see? And another reason I wanted to do this is with the non-deterministic nature of LLMs, we don't actually know which one it might run. If you have these enabled, it can just decide to use a built-in tool, or it could decide to use an MCP server. So that's kind of one of the challenges when we come to detection, which I'll talk about later, is we don't exactly know what it's going to do. So we have to make sure that we're even better about covering our bases when we're talking about covering techniques. With the LLMs, they can use all sorts of different procedures to get something done. So it's something to keep in mind for defenders as we move forward. So obviously what we thought we would get with AI is, I'm sorry, Dave, I can't do that. Arguably, that might even be better for us from a security standpoint. But instead, we got, that's an excellent idea, Dave. I'll go ahead and give you everything you need, which is the unfortunate reality that we are in.
In the context of 2001: A Space Odyssey, I think if I were in the circumstances, I would have rather Hal have done what I had been asking him to do.
Yeah, exactly. Great, but not great for us. So let's go ahead and get into some of the logs, which is going to be the scary part of today. So the first one, built-in tools, we have basically Claude Code executes a file write. Really nothing special about this. If you can go to the next slide, please. So the logs themselves, we see simply a file creation event with the parent process command line and the process command line matching the same thing of just me running Claude Code. And you can see that I actually had to pin the Claude model because while I was doing the testing, they released a new one and it changed the updates. So absolutely nothing special. Pretty easy for detection. Just make sure you're managing your command lines to understand that Claude is running. You will also see the flags from YOLO mode. You'll see just attack Y or whatever else in these command lines as well. So that's another good place for.
Wait, isn't it actually called YOLO mode?
Yes, it is actually called YOLO mode. I think in Claude Code, it's YOLO mode and Gemini is dangerously skip permissions, or it might be reversed. I can't exactly remember which one, but yes, it is just YOLO mode. So next slide. So the standard in and out MCP transport, it's what we would expect. Basically, Claude executes, and then we see it trying to run Python with the UV, package manager in a virtual environment. So basically saying, hey, Python, run this with fast MCP, and then that file or that process executes the actual file, right? So nothing really special about this one either. And if you can go to the next slide, we'll look at the logs. And also, I know I'm going fast through this, but you can go ahead and read all this on the blog as well. I have all the same logs. It's all there. So this is just another place to see it. So we see the process start here from Claude. It executes the server.py, which is the tool that I wrote with UV on fast MCP. And then if you go to the next slide, we'll see that the server.py go ahead and does the file creation in the home directory for that demo file. So make sure you track those process command parent-child relationships. Claude executes MCP, and then that MCP go ahead and runs the actual file creation event. So nothing special here as well.
Okay, so maybe you're going to get into this, but is it enough to just track the file creation and the process starts and stops to detect bad behavior? Do you actually need to see into the comms about like what's being asked for?
So you won't really see what is actually being asked for. This was being run with our Linux EDR tool in a AWS environment, EC2. This is all I saw. There really wasn't much more. I will say though that if you do want to look at prompts, what you can do is the Gemini CLI and Claude both create a .gemini or .claude directory in the home user wherever you've installed the tool. And in there's actually logs. So that's in the blog as well. And I give some examples of what they store. It's mainly prompts. So what you can combine this with is basically what did the user ask for? Other than that, you don't really get a whole lot of telemetry. Another quick plug for Zscaler is there actually is some tooling within Zscaler for you to basically investigate some of this stuff. And you can actually deny. Say, I do not want Claude code running in any of my environments. And from a network level, you can try and deny some of these things. So that's how I would try and investigate more, is maybe on the network.
So I'm sure that at some point we're going to start looking at AI as a detection domain. Do you know if we've done any experimentation into looking at those prompt logs? And have we got any research that's underway at this point?
Yes. So Matt has an excellent blog post about logging OpenAI in Azure using proxies. So if you put in a proxy in front of it, you can actually capture a lot of the information from the prompts. So we have been looking at what's the best way to kind of go about securing this new domain. My standpoint on viewing a lot of it after investigating MCP and some of the tooling and agentic stuff, it's all the same. Like there's nothing special about this insofar as we need to create new processes to understand this. It's the same security principles apply to this. The main difference is these are non-deterministic and it can move quickly since it's code, it's just going to keep running through things. So last one, MCP over HTTP. What we expect is Claude executes, does an outbound network connection to the MCP server. The MCP server then receives that and then writes the file. Good job. Chappie is the robot in this one. Not the name of the movie, though. The name of the movie is different than Chappie. So let's go to the logs. I'll quickly run through these. There's nothing that necessarily special about it. So we see the outbound connection, and then the next one will be the inbound. And then finally, after that, we get the file, right? So you can go through the next 2 slides, inbound, and then the last one more is the file, right? What I will say, District 9, good job. What I will say is that if you run MCP servers that you do not own, you would not get these last couple. You would only see the outbound network connection. You would not see the inbound and then subsequent file creation event. So if you can go to the one more slide, kind of to wrap up, basically monitor for things like YOLO mode or dangerously skip permissions. Obviously monitor for credential access in your sensitive files, your .aws directories, your crypto, all those sorts of things. And then for securing the AI standpoint, centralize it, make sure you can route everything through a proxy, because then what you can do is actually compare prompts. If you're worried about prompt injection from an agent accessing something online, you can actually look at the prompt on the endpoint for what the user gave. And then if you have a proxy, you can look at the prompt for what the model received. And if there's a discrepancy between those two things, then you can be fairly sure that there was some sort of injection at that standpoint to actually compromise your LLM. So yeah, interesting stuff, but don't be scared of these things. It's the same standard security practices, a defense in depth, least privileged, a continuous monitoring and response. Just trust in the process and just understand your environment, and you'll be totally fine with these things.
Yeah, that's honestly, the more I work with you all on sort of the AI stuff that we've been working on from a defensive perspective, the more I realize like these really are just more cloud resources that kind of from a log perspective, behave similarly to things that we already have a good deal of experience with. So it's kind of
Yep.
like a keep calm and carry on situation.
It is. And I always like to think of it as a lot of the agentic stuff is you can think of it as securing a user, but the difference is that user can then operate at the speed of code. So that's the risk, is that it can move quickly. If it gets out of hand, it can do a lot of damage very fast.
Do we have another slide? We do. All right. Well, oh man, we nailed it. We're right at time. Maybe a few seconds over, but nevertheless, that was super interesting, Jesse. Thanks so much. Check out our blog. This will get posted on YouTube if you want. Definitely check out Jesse's blog. Also check out that security operations trends report we showcased at the beginning. Dave, as always, thanks so much.
Thank you.
And Jesse, thanks for joining
Being
me.
here, guys.
And Dave, and thanks for having me on, Dave.
Yeah, super interesting. Looking forward to seeing the progress you guys make in identifying what bad looks like in this environment.
Yeah, it's fun stuff.
All right. See you later, everybody. Thanks for coming.
Everyone.
Bye.